Hello everyone, hope you guys are doing absolutely fine. Today is day 22 of our 100 days of UX challenge, and today we are going to talk about vision prototyping and AI ethics. And this will be the second last video for this book series, and we have finished this book almost in a month, so that's a great achievement for us. And we have like extensively discussed all the topics within this book. So let's start with today. uh, See now, the first thing which I want to highlight over here, which is Gen AI can replace a moderately sharp research intern. Okay, this is what we need to understand, that uh, a normal researcher will be replaced by AI, or a product manager who is new to the industry being studied. So because of the AI tools are getting so much advanced, that's the reason. And extracting and summarizing insight is a key step in most research studies, and one should leverage really good AI tool for that. uh, there are so many tools which we can use for leveraging the analysis part of the data. That there are so many tools which we can use for that. Let's see now what is the vision prototyping, and what we are going to learn over here. So let's start with this image. Okay, uh, so what we are doing here, we are actually trying to ask tough questions to all the stakeholders who are working with this product. So the first thing is, let's understand this guy is doing at with this pipe. So it's an industry level machinery, and there are so many fluids and liquids which are uh, pushed through these pipes, and to do various operations on those particular fluids. It could be it could be a mix of fuels, or it could be a mix of different liquids which could be corrosive. So this pipe will actually get corroded after some time. So what we can do to understand or to know when this pipe will be broken, or just there will be holes in it because of the rusting, excessive rusting. So this guy has some instruments. He's actually, what he is trying to do is finding the remaining diameter or remaining thickness of the pipe. And for that, he is using machinery. Okay, now over here, if you see the graph, it's a decay of pipe with time. Okay, so remaining, so on the y-axis you can see the remaining pipe thickness. So when you start, so your pipe is like really thick. If you see the first point, okay, the pipe with time is actually less. So you have just installed, and your thickness is like proper, but then over the time the thickness actually getting reduced. Okay, this is the pipe thickness. So suppose this is like 10 centimeters, then this will be 8, this will be 6, and this will be this orange line, this will be the point when you are actually in danger, that this pipe can burst. um, so this is a simple algorithm, right? This doesn't have that much of AI depth in it, because it's not a complex calculation. It's a linear equation or something where you can find. So then when this pipe will, you need to replace this pipe at this point of time. Now let's understand this accuracy and preciseness of the results. uh, See, the first result is accurate but not precise. Okay, when accuracy means very close to the center. So if you average it out for all the points, it will come within the center, because all everything is like really all the average of all these points is within the center of this particular target. And in the other one, all the results are near to a grouping. okay. So it's very precise, but it's not like completely accurate, because there will be some machine biases or measurement biases because of that, but it's kind of precise for all the points. So then your sensor, whatever sensor you have used for that, counting that thickness, it's not, you don't need that to be very much accurate, but it should be precise, it should be reliable, that every time it will be going to give you a very precise outcome. So based on that you can actually error it out, that like you can see like how off that is from center, and you can manage it. So this is the concept which we need to understand. And then the author has actually done some wireframing of it. So let's see this in a little bit of detail. So what author has done over here, see the top section is, it's showing you the sections, different sections of the pipe where the measurement is being taken. Okay, now you see the graph below, okay, where you are seeing this particular, so first of all we saw this pipe, okay. Let me just do it like this is the pipe and these are the sections. So suppose your cursor is coming over here, you can see the details or data of this section. Then if you just click this, you can see this section. But now let's see what you are going to see if you click on this section. So now you are seeing this graph, okay. What is this graph? So it's showing the critical, warning and average for this type. Now what is this warning? What is the critical, what is the warning, and what is the average? Now you see this is the average, around like 2.4, 2.34, and then you have this warning, then you have this 1.5 is your like kind of you are going into critical part of the the decay. So once you reach over here, you are in the critical part. So that gives you understanding, okay, I need to change the pipe at this point of time. And also what author has done is you are creating actually scenarios, okay. So your rate of corrosion depends on all these data points. Like if you see on the scenario 1, there is a temperature, there is pressure, even there is the most important is material, and then there is your, what is your section type. It's a mechanical naming of the particular pipe that we don't need to understand, but yeah, it's there. Then your flow, like how much you are flowing the liquid from the pipe. Then your corrosive liquids, like do you have H2SO4, like how much, do you have HCl, do you have CO2, do you have ammonia. And current minimal thickness, you can actually define it, and current wall loss. So based on your previous data, you can even feed this data and create one scenario. Based on that, you can create different scenarios for different sections of the pipe. Suppose in particular section of pipe there is only one liquid going on, where H2SO4 is too much, but in another pipes cross section you are not flowing that liquid, because maybe you have processed it and now that HCl is not present in that one, so you will only have H2SO4, something like that. So you can create different scenarios for different cross sections and get an estimate there. So yeah, this is called vision prototyping. You can create a mock-up of like what you feel based on the data you have, and you can create a UI. And now you ask like some tough questions. So like let's understand the vision prototyping best practices. So what you should do if you are doing this kind of prototyping. So start with play, okay. So give yourself and team to have little fun. Okay, what do you mean by little fun? So this is one example, that just what the hell is AI supposed to predict in this case, because it's a linear equation, right? The corrosion graph is so simple, a middle schooler can predict when the pipe will burst. It's a simple linear equation, right? We don't need too much of AI intervention in this. It's a simple linear equation. So you can ask that, okay, what is AI actually doing over here? Why can't another algorithm can be used just to get prediction? Then imagine and walk through the various scenarios. Practice bookending techniques, which we have discussed in the previous or maybe previous to last video, where we described about when you are iterating on something, you find a solution. I mean, you find one way of iteration and then you just leave it and start with scratch. So the new approach should be like completely different from the previous one. So that's called book ending. So you are finishing one book, now you are taking another book. So in one book there will be concepts similar to one, right? So it's like one button you have put on the top of the screen, but in the another iteration you have just shuffle that button somewhere else. So that's not called bookending, that's part of that book. So there are some iterations which will be like similar to others, so we don't have to waste our time there. We just finish that and just put it over here, and then just start thinking completely differently to get completely new iteration. Then set your ego aside and get genuinely curious, because that's what is really important, where you have to ask the questions which you think you will appear silly if you ask, but you have to ask. Lead the exploration in a light-hearted, fun and casual way to avoid pissing people off with your uncomfortable probing question, because you have to ask probing questions to get to the meat of it. All you need is a light push in the right direction. Okay, remain humble, patient, caring, yet persistent. You have to find the answer, but you don't have to be rude to find the answer. You can be humble and patient and caring as well. Now assume realistic constraint. Okay, just what the hell is AI supposed to predict? So now you understand, right? So constraints are fuel. Okay, they are what makes the design move forward. So the how many constraints you have, based on that you have to be a little more creative, and that actually helps you. Constraints are fuel. That is what I have experienced. When you have like lot of constraints, then you will be better able to find a solution or find some better iterations for that problem. Play the omnipotent AI game. Okay, what if you had the almighty AI? So now just it's about like your thinking very widely, where if you have the like godfather AI, like what you are going to do. If you have the almighty AI, so then what will you do? Like what would you be able to do with it? How would you deliver value to the customer? If your AI can do anything. So this is also important to just understand like limitations and constraint of the AI, and ask questions like how is this information valuable? So what would make it valuable? This is very important. Ask what would make this integration of AI valuable. So how is this information valuable? Because you don't know the answer, you have to ask these questions to get the answer. And what would give us that information? Okay, what could accomplish this desirable decrease in rate of corrosion? Okay, in this case you can ask like what could accomplish this desirable decrease in the rate of corrosion, because there will be some liquids you can actually by some sort of coating you can decrease the corrosion, but like what else you can do? You have to understand why you are choosing this AI. Is there any other solution available without using the AI? And you can follow the data. Okay, ask questions like who has the data we need to train our model, how do we get it? Okay, and do the digital twin exercise. It's ideal for this type of analysis with a group. Now digital twin exercise we did in the earlier chapters, where we wanted to create a digital model. In that we were actually seeing all the, what is the data, what is the AI model doing, how accurate is it, or what is the rate of false positive, false negative, and everything, so that we can check what the data has and go into the field, because it's important for researchers. You need to understand what people are thinking, who are operating these machines or doing these activities. So you have to go to the field to understand all the moving parts, artifacts, and challenges different crew encounters while doing the installation, because all the crew members will have different difficulties. So if you understand that, you will be in a better position to solve those problems. And there is no substitute for first hand field research. You have to do that. You can't rely on a subject matter expert, because you need to understand the complete picture, which is very difficult to share by someone verbally. You need to go there and understand everything. So just do like couple of field studies with AI tools, if you are using these AI tools in some different environment. And it takes a village. Okay, now this is like quality of your questions are important. Never let the good crisis go to waste. Okay, never let the good crisis go to waste. Leverage co-creation and participatory design with customers and vendor. So you have to do some co-creation design activities with those people, because ultimately they are going to use it, and those are your users. And if you can do the first hand study with them, then that would be the best thing you can do in that case. So co-creation and participatory design activities are like really fun to have, and you will see a different perspective. So all the assumptions will be checked there and there. Okay, and use brainstorming techniques like 6 heads or jobs to be done to have more structure for the meeting. So these are like, you can search it on Google or any AI tool, what are the 6 heads techniques, and what is the technique called jobs to be done. Okay, based on that you can solve that. And let's see mistakes which we can avoid in doing some of this vision prototyping. So first is, don't aim too close. Okay, don't just show a bunch of screens, because you have to you have to make them understand the scenario. So you have to use that very smartly. Don't just drop a Figma prototype, it's not important. You have to make them understand that you are solving something, so you have to show them the purpose of doing this activity. Okay, and don't use lorem ipsum and everything in the prototypes, because you want to make it real, because people are going to make their understanding not just by how it looks, but by the data you are putting there. And don't worry about every possible corner case, because you are just iterating for the first time. So you need to understand that okay, it's okay to cover some main use cases, not everything. And don't confuse prototype with implementation can be different, but it's a prototype, so you have to make sure that users are clearly understanding this is not the final product, but this is the idea we are trying to check with them. And you don't get too attached with any of these solutions, because I know designers can be a little bit of possessive on their idea, but you have to live and let go of such ideas. And yeah, that was the vision prototyping. Now we will be seeing some of the biases in AI, and this is the chapter 21, I think. Okay, yeah, this is the chapter 21. Let's understand what is the biases, right? So this is the search we have, the author has done, which is like searching chemist or biologist. So then it shows a woman in the lab. The woman is also Caucasian, so she is from some of the country like US, Russia, or some European country. So what is this? This is a bias, the white bias, you can say. Then if you search about like these are the Mid Journey results. All the males you can see are the white males, right? There are no girls, just one lady you can see over here is over, and the fourth row and the third result is of a lady. So it was a simple prompt that give me a image of a biologist. So then there is a gender bias, you can see. Here if you see the NBA players, the basketball players, you will see all the males, right? There is only one representation of female, so it's also a gender bias and the color bias as well. So you can see all the first two are the white males, and then like you can see like couple of black, then white, then all the black, and there are like couple of white males in between here and there. So there is some bias there as well. Woman in depression, so this was the prompt, and you can see there are so many results. Or I think a depression, in these results you can see the male results as well. The prompt was not woman in depression, the prompt was a person in depression. So you can see all the depressed images are of female, only a few of these are of male. So always assume that AI is biased and figure out how that bias will impact the experience. So this is very important for us. And then this is one example when it's in World War One or two, I don't remember, but this example is also shared in this book, where now you can see this image. You might have read it or learned it by some of your teachers, professors, maybe back in the day. I have like understood this when I was in NID. This was I think explained by one of my professors there. So what is it? See, this plane actually came back from the fight. There are so many bullet holes in this plane, and it came back. So ideally, what a person or what an engineer's team will do is fix this holes with much more reinforced material. But then some radical thinking came, and they understood that okay, this plane is not crashed, okay, it came back, so it's still safe. So if you get bullet holes in these areas, you still can fly, right? So what are the critical areas? So critical areas are those where the bullet is not hit, okay. So if you see this blue box, I'll show this part is very critical. There are no bullet holes in that because there is engine and there is nose, cockpit, and then there is a second part which is over here. You can't see any bullet holes in this. So these are like two critical parts. So what engineers did, they actually reinforced this part because you don't want to waste your engines and the cockpit, as well as the rear area, where this is not a fin area, this is like kind of maybe fuel must be stored there, but these are like really crucial areas where they actually reinforced, and it was a success. Okay, so this is how you should think about the biases we have. So we try to fix whatever is broken, but sometimes it's broken and it's not hurting, then it's fine. You have to see what could be the catastrophe if you have a bullet hole in your engine. And other planes were not came back who had bullet holes in the engines or this the rear area. So that's how you have to think in terms of AI and in terms of the errors. uh, yeah, we'll be seeing this chapter tomorrow. This is called AI ethics. It has a lot of things to cover, so we'll be seeing this tomorrow, and we'll be most probably finishing this whole book tomorrow. So yeah, thanks for joining in, and yeah, stay tuned for the next one. Thank you.